A student taking a multiple choice quiz forgot to study, so he's going to randomly guess the answers to the questions. There are 12 questions, and each question has 4 multiple choice answers. Only one answer is correct for each question. We're going to use binomial distribution for this because the only outcomes for this is that he gets the question right or wrong. We're going to use, if he gets the question right, as success, which means the probability of success would be if he guesses it right. So the probability that he guesses it right, since there's 4 answer choices for each question and only one has the correct answer, he only has a 1 in 4 chance of guessing each question correctly. And we'll label that in decimal form, which is 0.25. Our number of trials is going to be 12 since there's 12 questions. He's doing this 12 times. Okay, so now where it says find the probability that he answers 6 of the questions correctly. 6 of the questions correctly means we're looking specifically at one value. That is just the value of 6. So in this case, we're going to use the binomial PDF. So I'm going to do binomial PDF. The number of trials, that's your n, which is 12. My probability of success is 0.25. And my value of x is going to be 6 in this case. We're only looking at that one possible outcome, that you get 6 successes or 6 questions answered correctly. Now, when you put that in on your calculator, you should get a decimal approximation of 0.0401 when you round it to 4 decimal places. Okay, the next part says find the probability that he correctly answers 3 or fewer of the questions. So when we look at the number line, 3 or fewer, that's 3, 2, 1, or 0. Anything 3 or less would be what we're interested in. So we're going to use in this case the binomial CDF because we want to look at the accumulated probabilities up to 3. So we're going to use binomial CDF. Our trials is 12. Our probability of success is 0.25. And then our value of x for the accumulated x is 3. When we put that in on the calculator, you should get approximately, when we round it to 4 places, 0.6488. Okay, now part C says, find the probability that he will correctly answer more than 8 questions. So when we look at the number line, more than 8 means he's going to answer 9, 10, 11, or 12 correctly, which means since we can only do the accumulated CDF, we can only go from 0 and up to a certain number. We want to use the complement and find everything up to 8, the CDF for 8, and subtract it from 1. What would be left over is from 9, 10, is from 9 and up, basically. So we're going to do 1 minus the binomial CDF. And we're going to subtract off the CDF of all the values from 0 up to 8. Now, when we do that, we're going to get a really small value. We're going to get 3.9 e negative 4. But when we write this in standard form instead of scientific notation, that means we have to move the decimal place over 4 places. So that will give us 0.006 0.039 when I take this and I move it 4 places this way. And if we round it to 4 places, that will be 0.0004. Okay, part D, find the probability that he correctly answers 5 or more questions. Okay, 5 or more means that we're going to include 5 in this one. And the other one in the previous part, it says part C, it's more than 8. So we're not including 8. It's more than 8. So we're starting with 9. In this case, we are including 5 or more. So we're going to do 5, 6, 7, 8, 9, 10, 11, and 12. Which means we want to use the complement and subtract off the CDF up to 4. So we're going to do 1 minus the binomial of CDF, and we're going to use 12.25, and then we're going to go up to 4. That's what we're subtracting off. And then what's left will be what we're looking for. Now when we do that, we should get approximately 0.1576 when we round it to 4 places. The last question says, find the probability that he correctly answers fewer than 2 questions. Fewer than 2 questions means you're not including 2, it's less than 2. So either 0 or 1. Now here we can use the CDF directly without having to subtract from 1 because we're just adding up everything up to 1. So I'm just going to do binomial CDF 12.25, and we want to add everything up to 1. So 0 and 1, which means my value of x should be 1. Now, when we put that in on the calculator and we round it to 4 places, we get 0.1584.